8th graders, last little Amplify lesson for you guys that I kind of pieced together over a couple to kind of lead us into our next week's lab over science of a chemical reaction. So first and foremost, this is 3.4 chemical reaction and your learning targets. I can identify the products and reactants in a chemical equation. So we're going to wrap up our little mystery that we were solving about the water in Westfield. And then I can conclude whether or not a chemical reaction has occurred based on the 5 signs of a chemical reaction. So earlier in this unit, we talked about chemical versus physical change. But now we're going to put some actual identifiers on chemical change to identify, have we actually created a new substance? How do we know? Okay, so let's go ahead and kick off with our warm-up. You guys should have completed the activity 1 warm-up. Remember, whether you guys are doing this at home or you guys are sitting in class right now, after each section, pause, okay, finish up this section, and then move on to the next part of this video that'll explain the next activity, so on and so forth. Okay, so you guys in class should have already completed the warm-up as you came in today. You had this message from Dr. Young. Thank you for your explanations. The people of Westfield now understand how the rust in their water could have formed from a chemical reaction between the iron pipes and the fertilizer. However, before the townspeople can consider this mystery solved, they need to be certain that the chemical reaction between the iron pipes and the fertilizer didn't produce any other substances. So did it just produce the rust, or was there more than just the rust? So that's what you guys are going to be exploring for the first part of this lesson today. Okay, at this point, your guys' computer should be facing forward, so you're paying attention to this video. You guys, again, should have already completed this warm-up. Okay, moving on to the second part of the warm-up, you guys see this is kind of your little chemical equation so far. We had 2 iron atoms coming together with 3 fertilizer molecules to form a rust molecule. Okay, so with that being said, you guys should have answered this question. What was produced during the reaction between the iron pipes and the fertilizer? So you guys should have used your draw tool to circle either claim 1, during the chemical reaction only the rust was produced, or claim 2, during the chemical reaction the rust and another substance were produced. And then you guys should have explained your answer there. Okay? So go ahead, if you guys haven't already, take a second, pause, finish that up. No more than a minute or 2 to do that, as you guys should have already had it done when you came into class. Okay? And we'll go ahead and move on to activity 2, which is a little hands-on activity. All right, so a couple days ago, you guys, when you did 2.3 and 2.5 chemical reactions, you guys put together a little experiment. Again, at this point, if your guys' computers aren't facing forward, please make sure they are so you can pay attention. Okay, you guys put together a little experiment where you guys added some iron to a cup, and then you guys added some sodium nitrate, which is the fertilizer, to the cup, and then you guys added some water so they could react. Okay? You guys saw the next day that they did in fact form a reddish brown substance, which we can assume to be rust. But the question that you guys are asked right now is there anything else produced other than the rust? So at this point, you guys are going to pause this video here in a second. You're going to go back. You guys set those cups under the windowsills to dehydrate. Okay, just because we see just the rust in the water doesn't mean that there isn't something else dissolved in the water that we don't know about. So we sat those cups in the windowsill so the water could evaporate. And what we should see left is any other products, if there are any other than the rust. Okay, so go ahead, pause this video, go grab your cups out of the back windowsill, and then make some observations on those. Okay, and type your observations right here. And then answer this question. What do these observations tell you about the other products that may be produced other than just the rust? DLI, here's your video to watch right here. Okay, so pause this video right now and go do that. All right, so you guys should have just written your observations, and you guys should have answered your questions about any other potential products that could be formed other than the rust. Okay? All right, let's move on to activity 3. Again, your laptop should be facing forward right now. All right, so what you guys see is we obviously had some kind of white crystallic structure that formed other than the rust. We didn't just see rust left over after all that water had evaporated. So what we know is 2 iron atoms come together with 3 NaNO3 molecules to form Fe2O3, which is our rust, and some other unknown substance. So you guys have 2 kind of claims as to what this substance could be. You guys could think it could be either sodium nitrite, NaNO2, which looks like this, or it could be a potassium chromate, which is K2CrO4. So here's what potassium chromate would look like. Okay, so with that being said, you guys are going to circle what you think is most likely. So based on these atomic scale models, what other substances could be in the water besides rust? You need to review back to slide 7. Again, take a look at slide 8, has your 2 possible other products, and then circle either sodium nitrite, potassium chromate, or you think that both could be in that leftover product, and then explain your choice right here. And then finally, you guys will use the sorting tool. You can right click that link, open it up. Here's your sorting tool. You guys, just as you had before, can build your 2 products. So make sure you guys put 2 irons here. So there's my 2 reactants. You guys are going to build your reactants first. And then your products are 3 NaNO3s. So you need to do 3 of them so you guys have the correct amount. So we're going to go sodium. Ooh. So Na and then NO3. There's 1 NaNO3. And then you guys can build the other 2 NO3s on your own. And then what you guys will do is you guys will rearrange your products to form, first and foremost, Fe2O3. Remember, you're not grabbing new substances for this. You guys are using the old ones. You again will have 2 more NaNO3s to look at, and then you guys will rearrange those to see what else you can form from this. Okay, and then tell me which one you think is going to be the likely product between sodium nitrite, potassium chromate, or both. Okay, and then finally take a screenshot of your final products. We've already kind of started to build the final products. So once you're done with this, take a screenshot of your little sorting tool and insert it right there. And then finally, write the coefficients in the balanced equation below to show the final balanced reaction between the iron pipes and the fertilizer. So remember, if you don't write a number there, we're going to assume there's one of them. If there's more, like for instance, we know we used 2 irons, so you guys would write a 2 in front of there. Make sure you guys use your draw tool. We know we used 3 NaNO3s. Okay, so go ahead and finish coefficients for these 2 as well. And then go ahead, pause that right now. Take a minute to finish slides 7 through 12. And then when you come back, we'll work on activity 4 together. All right, welcome back. Let's go ahead and take a stab at activity 4. You guys will be doing modeling similar to what you did a couple lessons ago as well. I think that was also 2.3 and 2.4. Okay, so you guys will be using the modeling tool on slide 15. I'll show you guys that really quick first. Okay, at this point, again, your laptop should be facing forward. So you guys can see the before box is already done for you, and they did kind of a little atomic scale model there. Okay, so use the modeling tool, products of the reactant sheet, to help you explain to the people in the Westfield what is in their water. So goal, create a model that shows what was produced during the chemical reaction between the iron pipes and the fertilizer. So we obviously know rust was produced. What else was produced aside from the rust? So do, in the after space, draw an atomic scale model of what was produced during the chemical reaction between the iron pipes and the fertilizer. So the last model you guys drew, you were kind of at liberty to draw whatever you wanted. This one's asking for the atomic scale model. And again, that looks like what you guys see in the before, where we drew the little circles, and those are going to represent iron, sodium, oxygen, nitrogen, all those things, okay? It might be helpful to just color coordinate these and be like, all right, my irons are going to be orange, and I'm going to circle those in here. And then over here, I'm going to make a key that says iron, okay? And that way you guys don't have to keep drawing these little circles and writing Fe in them. The next time you draw them, you can say, all right, I made iron oxide. Here's 2 irons. And then say my oxygens were red. Okay. Then I can just go, all right, here's my iron oxide. Here's my key. So that's up to you guys. Go ahead and model what you guys produce other than the rest that I kind of already did for you. Refer back to this if you need help. Okay. Color the atoms using the key found on your screen. Again, you can make your own key. And then during the change space, describe or draw how the products or products were formed. So you guys can either draw how the products were formed, or you guys can write. Remember, if you would like to type, you guys can go to Insert, text box, and then you can click and drag this, click and drag this text box wherever you need it to be to type and describe what happened, okay? And then some tips for you: an atomic scale model of the iron pipes and the fertilizer is already shown. Use the substance reference guide provided on your screen. I didn't provide that. Did I provide that for you guys? And then you can draw more than one repeating groups of atoms. So here's this kind of as your guys' substance reference guide to help you guys build those potential products. Okay, so go ahead, take a second, pause this video right now, and you guys can finish slides 13, 14, and 15. All right, welcome back. You guys just finished up the modeling tool on slide 15, so go ahead, face your computers back forward. Next little part that we're going to kind of shift gears is now we've finished kind of answering to the people of Westfield what the mystery substance could have been in their water. We're going to go ahead and shift our gears a little bit to get us ready for our lab next week, and we're going to start talking about signs of a chemical reaction. So at the beginning of this lesson, I talked a little bit about how we did a lab not too long ago over physical change versus chemical change. And you guys kind of learned, all right, if we are forming a new substance, that's chemical change, but how do you know? Okay, I think you guys did pretty good with that lab, taking a stab as to whether you guys thought it was physical, it was still the same substance, versus it was chemical, it was a different substance. But we're gonna put some actual identifiers to these things that we're seeing happening in a chemical change that tell us that we've made something new. Okay, so to start us off, we're going to go ahead and right-click this link right here, and you guys have a little video to open up. You guys have watched it already, or you guys haven't watched this one yet. So you go ahead, open up this video. It's called Sodium and Hydrochloric Acid. So they're dropping a piece of solid sodium metal into some hydrochloric acid, or HCl, and observing what happens. So in this video, there's a chemical reaction that occurs, so we see a chemical change. What are some observations you notice that can support the fact that a chemical reaction has occurred? List as many as you can. So go ahead, I want you guys in class especially to take a second, watch this video first, and complete slide 16. So pause the video, show this video up on the main screen, and then answer this question. Once you guys are done with this question, flip your computers around, go ahead and pause. All right, so you guys have written down everything you thought you saw happen that could have indicated that we formed something completely new. Okay, but let's actually add some things to our notes here. Okay, so there's 5 signs that a chemical reaction occurs. A color change, remember this wouldn't be a color change that we would see like just mixing 2 colors like red and blue equal purple. Okay, it's gonna be generally a completely different color change, something that's a little abnormal to what you think you would see if you mix 2 colors together. Okay, formation of a gas, basically you guys see it bubble. Formation of a solid, we call this a precipitate, and this one sometimes is really hard to see. For instance, when you guys did the chemical versus physical lab, the first lab you guys did over there, you had 2 clear substances, and when you mixed them together, it turned white. Okay, not only is that a color change, but if I were to take and filter that out, okay, we would have like a white powder in that filter when we're done. So that's formation of a solid. We call this solid a precipitate. Okay, so if you guys think that that's something that you guys could filter out, it's obviously something that formed into liquids that had things dissolved in them. Okay, it's obviously something that formed and is no longer dissolved in a liquid. Okay, so that's formation of a solid. You could filter it out and have a powder. You could even compress that powder together to form a solid. Okay, chalk is made from this process. So if you guys look at sidewalk chalk or marker board chalk, oftentimes you guys can form chalk by taking 2 clear substances where everything's dissolved in them, mixing them, forming that white precipitate, and then filtering that precipitate out and having chalk. Okay, change in energy. So this could be, you know, it turns colder, it turns hotter, it produces light, produces different colors of light, those kinds of things. So we have some kind of show of energy. And then finally, odor change. You guys, this is probably less obvious and hardest for you guys to observe, especially those of you guys working at home. But what I want you guys to do right now is open up your OneNote. And you guys need to add these notes into your OneNote. So you guys have signs of a chemical reaction in there. So here's my OneNote. Under my section, chemical reactions, you guys are going to add a new section titled Signs of a Chemical Reaction. We're going to be using these all next week. So again, here's my chemical reaction section. You're going to go add page, and then you're going to add signs of a chemical reaction, and go ahead and insert this little blurb of notes into your notebook. So go ahead, pause this video right now, take a chance to add these into your notebook, and when you're done, go ahead and flip your computers back forward. All right, moving on. So next 3 slides, you guys have 3 little mini videos to watch that should be familiar to you. You have either done these little experiments in class, or you guys have seen them happen on videos from Amplify. So this first one, you go ahead and right click that one, open it up, and you guys should get this burning piece of paper. So rewatch that video, and then here I want you guys to circle all the signs of a chemical reaction that you see taking place. So do you see a color change? Is there an odor change? Okay, you guys know what paper looks like when it smells. Okay, so change in energy, formation of a gas, formation of a solid precipitate. So do we have basically a solid form out of 2 liquids? Okay, or 2 dissolved liquids. Okay, so go ahead, watch that video, circle all the different signs of a chemical reaction that you guys see take place when this paper is burned. And then you guys can move on to this next one. The next one was the baking soda and vinegar reaction that you guys saw, so rewatch that. Circle all that occurs here as far as those 5 signs of a chemical reaction. And then finally, you guys had this little spot plate where you guys formed the red substance. So again, circle all that you guys saw happen there. So go ahead, pause this video now, flip your guys' computers around, complete slides 18, 19, and 20. And then when you're done with 20, go ahead and face your computer back towards the front so you guys know you're done. And then we'll move on to the last little activity here. All right, your last activity is activity 6, little reading. So you have an article to read here called Endothermic and Exothermic Reactions. So this one really focuses around that sign of a chemical reaction with the energy change, mainly heat. So some chemical reactions require heat. You have to heat them up to get them to go, and others produce heat. Okay, so go ahead. It looks a little bit something like this. Obviously, you guys can see a big change in energy anytime you guys start a fire. So that is light and heat that are produced. So that would be an exothermic reaction. Versus if you guys have ever done one of the crack ice packs, that would be an endothermic reaction where it kind of takes heat from its environment. And we learned all about heat transfer. So obviously, when you touch that ice pack, you're transferring heat into that reaction, and that's why it feels cold. Okay? All right, so what is the difference between an endothermic and an exothermic reaction, and how does an instant cold pack get cold so quickly? So answer those 2 questions after you read. And finally, go ahead, do your wrap up for the day and hand this in. You guys have a little bit of time to work on that, and then when you guys are all done, you guys may put your laptops away. I hope you're having a great day, and I'll talk to you soon. Bye.